Hi everyone! In this video, we will be showing you how we'll be fishing the fakes from the reels, our machine learning project on fake news detection. We are constantly bombarded with news from various sources, and a large part of those come from social media including Instagram, Twitter, Facebook, and so on. And in this huge sea of information, some are real, some are fakes. But what is so bad about fake news? Well, fake news is made to misinform and deceive audiences, providing them sensational fabricated stories rather than the truth. Which leads us to this question: how can we fish out only real news and ignore fake news? Well, you could surely go through each and every piece of news you come across, checking them manually, then deciding whether it's real or fake. But the problem is, it's too time-consuming and costly to do that. So can we do better? And that's exactly the aim of our project. We will be using the ISOT fake news dataset. It comes from the University of Victoria in Canada and contains true news obtained from Reuters.com, which is a respected agency. The data is split into true and fake CSV files, which contains the following features. Next, let me share about our project goals. We want to first identify the common words found in both real and fake news, which machine learning model performs the best in identifying fake news, and lastly, discover whether different text vectorization techniques can help to improve our model's performance. And how are we going to do that? We'll take the raw data and tidy it up using a Python library called NLTK. Then we will generate word clouds to gain insights into the data and train this data on different machine learning models and compare their performances based on F1 scores. Before we can train the data on different models, we need to perform text vectorization. We will be using two different methods, TF-IDF and Word2Vec. It helps us convert words into numerical features. Next, here we have 4 basic models and 4 ensemble methods that we used. After running the models, we evaluated their performance based on F1 scores, given by the formula on the right. A higher F1 score indicates a better performing model. After completing our experiments, here are our findings. These are the word clouds generated from both real and fake news. Overall, our models achieved higher F1 scores of around 0.9. We ran the models on both text and title and realized that using text generally yielded better results, evident from the orange bars. While running the models, we found that ensemble methods ran much slower. Lastly, TF-IDF generally gave higher F1 scores, as evident from the orange and red bars. In conclusion, we have managed to achieve our project aims. We found common words through word clouds, found that the linear SVC model performs the best, giving a higher F1 score in a short amount of time, and lastly, we found that generally TF-IDF performs better than Word2Vec. In the future, we will be looking at testing our model on different datasets to see if it works well in other cases and also explore deep learning models which could yield even better results.